Do you guys have those family games? Like you'll just be chilling, you know, mind your business around your family, and they're like, nah, come on, we're playing a game. Like it could be a board game or a card game, but you'll always just grind it out when you're with your family, you know? Well, for me, that game is Boerenbridge, which I think in English translates to Farmer's Bridge or something like that. I'll tell you the rules of the game in a sec, but all you gotta know for now is that I was king and I shall never be dethroned. You know, since moving out, I haven't been able to see my family much. And you know, I miss the sweet taste of victory. So in order to reunite my family and to continue my reign as the king of Boerenbridge, I'm going to remake the game online and then make an AI to play that game and destroy my family. I'm also going to go undercover and pretend the bot is playing it, but it's actually me. Don't pretend I'm playing, but it's actually the bot. You get me? Stick to the end, you're going to see that shit, yeah? But first, the rules! To start the game, deal out the full deck to the players. The game is played through tricks, where everyone has to put out a card. But before this, everyone has to make a guess. Your guess indicates the number of tricks you think you're going to win, out of the total number of cards for that round. The last player can't make a guess that makes the sum of the guesses equal to the number of cards, because someone has to lose, right? Now we move on to playing. Everyone must follow suit of the first card played that trick, otherwise you can play anything. The winner is the highest card of the leading suit, or the highest spade, because spades is the trump suit. Players earn points based on the number of tricks they guess correctly, and the game continues with one less card until one card remains. In the last round, you don't look at your card but you show it instead, and have to guess based on this. And well done, you've just completed a game of Boerenbridge, and the player with the highest score is the winner. Alright, so now you know how the actual game works. It's time to do some programming. We're going to be making the game in the best programming language known to man, you know, Python. And we're going to implement 3 main classes, and these are going to be game state, game engine, and game room. The game state just holds all the information about the current state of the game. Think number of players, scores, guesses, all that stuff. Here's what that looks like in our case. The game engine is what acts on the game state, which allows it to change. It implements methods like play step, which increments the state based on a given move. It also makes sure that no rules can be broken. Now that we've got a way to play the game, we need a way to organize this with players coming in from the browser. This is where the game room comes in. In the game room, we can make a new game state and pair it up with the game engine. Then we can add players to the room so they can all play out the game together. It's also really good for making the bots play against each other, as you'll see later on. You know, a little Boerenbridge bot fighting rink. Alright, it's coming up, don't worry. But to connect players from the browser to my little game, we're using the Python libraries Flask and Socket.io. I'm not going to get too deep into how these work, but Flask basically lets us display a certain HTML page based on whatever link the user is looking at. That's how we're going to show the web pages. And Socket.io lets us send messages between the user and the server. So if the user makes a move on their end, it'll send a message to the server telling it to update the game room and its game state accordingly. So with our newfound knowledge, let's build the website, shall we? And there we go. We've got a finished website, and I think it's looking pretty nice. But to demonstrate, I'm going to need a second player. So let's go get one. Play the game.
Right now?
Yeah.
Do I have to?
Yeah.
Fucking hell. If this is dead, I'm just not going to play.
The password is YAH. Y-E-H. Okay. Oh, that's crazy. So you can't guess 10. That's not too bad. No way I win that one. Are you fucking serious?
I'm telling you.
You're such a bitch.
I'm fucking telling you. Like,
what? That's so fucked up. You know that? Whoa. What just happened? How many cards do you have now?
I have 5 in my hand.
I have 6. Just keep going, I guess.
What the fuck?
That has never happened before. Alright, so now that the game works, the moment you've all been waiting for. AI! Boerenbridge is a tough game to play for a computer because of a few main reasons. First is the fact that it's an imperfect information game. This means that the computer doesn't have access to all the information about the game, such as other players' cards or the cards that haven't been dealt at all. Second is the randomness of the game. At any given point, there's an average of this many possible combinations of cards in play. That's a fuck ton. To combat these problems, we're going to be using an algorithm known as Monte-Carlo tree search. Specifically, the perfect information variation, which is kind of a shit name because it actually deals with imperfect information games, but you know, what can you do? I'm not here to judge, mate. But anyway, Monte-Carlo tree search works like this. Given it's a tree search algorithm, we're going to start from an initial node and explore out from there. These nodes all represent different states of the game, and are connected by an edge when performing a move from one state brings you to the next. Building out the tree gives us a roadmap of all different ways the game could be played, but we want to pick the one that results in the best outcome for us. So the initial node is the current state of the game, and we need to decide which route results in the optimal next state. In other words, we're trying to pick the move that gives us the best position for the next round. So how do we do this? The algorithm follows these 4 steps: selection, expansion, simulation, and backpropagation. We start by selecting one of the child nodes. If it's already been visited, we choose one of its child nodes, and we do this until we've reached a node we haven't seen before. Now we expand this node by... Yeah, so that was a fucking stupid idea. Monte-Carlo performs well when it's likely to see the same state multiple times, which for us and our number of states is never going to happen. So what we're going to do instead is from each of our possible moves, we're going to simulate a bunch of random games and find out which one results in the best average position. We pick the first child node and need to simulate the rest of the game, but we don't know any of the other players' cards. This is where the idea of perfect information comes in. We make a guess about which cards are in the other player's hands, which is just a random distribution of the remaining cards we haven't seen. This is called a determinization, and we've now turned it into a perfect information game. From here, we run a random simulation of the remainder of the game, and can get a score at the end by checking the absolute difference between the number of tricks guessed and the number of tricks won. Averaging this over a large number of games, with a different determinization each time, gives us the average difference resulting from the original move. And we should pick the move with the lowest score, because this should give us the best chance to be as close as possible to our guess. Alright, let's check him out, shall we? Let's give it a go. I shall dub him as Randy Simpson for random simulation. Alright, very nice. Good nickname. Sounds the same. Let's go. So let's have a little game with Randy. I'm gonna say a nice little 6 here, I think. Hey, see, look, he guessed 6. That's not an unreasonable guess right there. He's playing tricky. What the hell? See, look, he's making me think a little bit, you know? Like, his moves are fair enough. There seems to be some strategy going on. Yeah, Randy, you fucked up, mate. Unfortunate. See, look, I think he makes reasonable moves, but he's not that good yet. Alright, hearts or clubs right now? That's the question. He's gotta have a heart, right? No, he doesn't. I should have done fucking clubs. Oh my god. Hey, well, he beat me on that one. That's crazy. For that game, I had Randy running at 100 simulations per move. But theoretically, his performance should improve if we up that number. So let's give it a go with 500. Okay, I'll guess 6. Watch your move, Randy. So that took way too long. That was about 30 seconds for one move, which is just not fast enough to play the game. But we can fix this with a neural network. A neural network is just a series of interconnected layers of neurons. These are the input layer, some hidden layers, and an output layer. Each layer of neurons takes an input from the previous layer and applies a bunch of transformations to it. These are operations like matrix multiplication and activation functions, and the goal of them is to extract some sort of meaning from the features of the input data. So the network is essentially transforming the input in a way that brings it closer to its goal, based on some characteristics it's learned throughout its training. For us, we want to input the current state of the game and one of our possible moves, and have the network give us the score for that move. This is called a regression network, because we're taking our input and transforming it into a single numerical value. So now, I guess it's time to train the network. This is all the information we're going to need to represent the current state of the game. So this is what we're going to pass to the network as input. Then I forced Randy to play hundreds, thousands of games against copies of himself, all generating samples. And I was left with this. What you're looking at is over 1 million examples of hands played by our random simulation bot. I had the bots running at 500 simulations, so each of these examples represents 500 random games played from that game state. This is our training data, and we're going to use it to teach the network how to score moves. Alright, I'm going to let that train overnight, and we'll check back in the morning to see how it's doing. What the fuck? What the fuck are you? Wait, you want to play Boerenbridge? Okay. Ah! So now we have that rogue AI under control, we should have a pretty good bot to take on some excellent Boerenbridge players. Just to showcase the effectiveness of this new AI bot, I put 2 AI bots versus 2 of Randy for 50 games, and the AI bot came out on top, winning 33 games out of 50. 66% win rate, not too bad. Now finally, it's time to call up my parents and reveal what I've been working on for these past couple months. They just think we're going to be playing an innocent game of Boerenbridge. Little do they know, I gave myself a sneaky move button to play a move from the AI. And I'm only going to be using the button to play moves. So let's see if the AI can take down my family on its own. So I was planning to make a bot for this game, but unfortunately this took longer than I expected and I haven't actually made a bot yet. So we're just going to have a good little time. Welcome to Connor's Boerenbridge that I made.
Woo!
So how this game works is that one of us can create a game and then we can all join that same game and we can play a game of Boerenbridge together.
That sounds cool.
So, do one of you guys want to create the game?
Yeah, the password is woo with 3 O's.
Alright, woo, let's go! Let's have a look. What should I choose? 3. Doesn't this feel just like old times?
Can I just point out, everyone made their required strikes, so nobody wants anything anymore.
That's what you're gonna
Yes.
do.
Yeah,
So
that's why
you
I'm
can
gonna
have
do
it. You're
I've
welcome.
Fuck, okay.
Yeah, Papa. We know.
Alright. See, this game is rigged, because otherwise I would never lose.
Connor, number 1, baby, let's go!
What?
Unlucky. I wonder what I should choose here.
What the fuck? Ah, that's bullshit. How can he say 1 when he can see what I think he's seeing? I don't get it.
I'm confident. Fuck.
How can you say 1 when you see the ace?
Yeah, you know,
space?
I made a judgment call.
Yeah, at my expense, thanks. Game over.
Game over.
Yeah.
GG, guys.
Guess who developed the game and ended up on top of the leaderboard?
Well, I have
Yeah.
a little secret to tell you guys.
What, you could see our cards?
I couldn't see your cards, but the bot has been done for a while, and you just played against the bot and not me.
Really?
Yeah. So my bot has successfully taken you guys on,
That's very cool. That is very cool.
which I think is pretty cool.
So what have you been doing then the whole time?
I've been clicking a button that says "Make my move for me."
Oh my god.
So there you have it. I successfully managed to ruin my family card game by making a bot that can beat us all. But yeah, I put a lot of work into this video, so show it some love if you can. Leave a like or something, you know, the classic. And yeah, the code's on GitHub. If you want to check that out, link in the description. And thanks for watching. Bye bye.